Hi, this is Miss Sebastian, and we're going to go over Unit 1, Geometry, Lesson 5, Polygons and Angles. So, our first question is, which angles are adjacent angles? Now, think about the word adjacent. Adjacent means next to. So, we're going to look at several of these, and we're looking for something next to FBT. Notice every answer has FBT in it. So if I follow FBT, that is this angle. Adjacent angles are next to the other angle, okay? So that also means they share a side. So I'm going to look up here at GBM. If I look at GBM, that is this angle here. Notice they do not share a side. So GBM cannot be my answer. So that makes A not the answer. So I'm going to look at CBX. CBX also does not share a side with FBT. So that can't be my answer. XBG is our next one. So if we look at XBG, that is this angle. And that does not share a side. Oh, and this is T here, sorry. So MBT, let's see where that one is. I'll put this one as red. MBT does share this side right here with FBT. So D is our answer. D is our answer. Find the sum of the interior angles of an octagon. So an octagon has 8 sides. In geometry, we have this formula that finds the interior angles of a polygon. You're going to multiply 180 times the number of sides your polygon has minus 2. So if ours has 8, we're going to write it as 8 minus 2. The 180 is just going to hang out because we are not multiplying until we finish up with our parentheses. 8 minus 2 gives us 6. And now we can multiply by 180. So 6 times 0 is 0. 6 times 8 is 48. 6 times 1 is 6, plus the 4 we carried is 1,080 degrees. So you can do this with any problem, any number of sides. Just make sure to replace the n here with the number of sides that your polygon has. The measure of angle 3 is 127 degrees. Find the measure of angle 2. So we see the measure of angle 3 is here. That's 127 degrees. Then I look at the measure of angle 2. That one's this one. And we don't know that one. But notice that these two together, if I follow the line that they make, it makes this whole big long straight line. Those two angles are supplementary angles because they make that straight line, and a straight line adds up to 180 degrees. So I'm going to add up 127 plus our question mark. You could have named it X, you could have named it anything, but you're going to add those two together to get 180. Well, we don't know what our question mark is there. So we're going to do the inverse operation of adding 127. So the opposite is subtracting 127 from both sides. Now on the right, 127 minus 127 forms a zero pair. And so it goes away. 180 minus 127 gives me 53. So our answer here is 53 degrees. Find the measure of each interior angle of a regular polygon with 9 sides. So on this one, we still have to find the total number of degrees that this polygon has. So we're going to go back to our equation of 180 times n minus 2. Remember, the n is the number of sides that our polygon has, and this one says it has 9 sides. So we're going to say, okay, 9 minus 2 gives us 7. Then I'm going to multiply that by 180 degrees. So when I multiply that, 7 times 0 is 0. 7 times 8 is 56. 7 times 1 is 7, plus the 5 I carried from the 56 would be 1,260. But that's not our answer because it wants to know how much each interior angle is. There are 9 angles. So I'm going to say 1,260 divided by 9. So 9 goes into 12 one time with 3 left over. You may need it like this. So 9 goes into 12 one time. Bring down the 6. 9 goes into 36 14 times. Sorry, 4 times. I was reading the top number there. Sorry about that. And bring down the 0. 9 goes into 0 0 times. So this is 140 degrees. Five of the angles of a hexagon measure 85 degrees, 110 degrees, 135 degrees, 105 degrees, and 125 degrees. Find the measure of the missing angle. Well, we first have to start out with finding out how many degrees is in a hexagon. So we're going to start. It has 6 sides. 6 minus 2, that gives us 4. And 180 times 4 gives us 720. So I'm going to take this 720 and I'm going to subtract each of these angles up here. So I'm going to say 720 minus 85, and I get 635. Then I'm going to take that. I'm going to subtract the next one. Now you can do this on your calculator, but I'm doing it by hand. And you get 525. Then I subtract the next one. $525 minus 135 gives me 390. Oops, that one. Okay. Then 390 minus 105 gives me 285. So I've done that one. And then the last one. 285 minus 125 would give me 160 degrees. So your answer is A, 160 degrees. So the way we did that was just find the total number of degrees and then subtract each one of those that we knew to find that missing angle. If A and B are parallel lines, and the measure of angle 2 is 152, I'm going to label that real quick, 152, what is the measure of angle 5? So this goes back to knowing what these angles are called on parallel lines. So if we look at angle 2, that's here, angle 2 and angle 6 are congruent because they're corresponding angles. Angle 2 and angle 3 are congruent because those are vertical angles. That means angle 6 and angle 7 are vertical angles. So if you know that angle 2 is 152, you also know that angle 6 is 152. Well, angle 5 and angle 6 form that straight line, so they add up to 180, so I could just subtract those and get 28 degrees. So remember to go back to that corresponding and alternate interior 3 and 6 are alternate interior, and that means they're equal. So you can use that as well. Okay, identify the pairs of angles as corresponding, alternate, interior, or both. And this one I wanted you to find, let's see, angle 1. Whoops, there it is. Angle 1 and angle 4. So, angle 1 has a corresponding angle of 5. If you think about it, if you look at the top line, line L, angle 1 is on the top left of that one. So the same spot on line M is where 5 is. That's corresponding. Alternate interior, they would both have to be inside, and alternate interior with 5 is 2. With that being said, angle 7 and 4 are alternate interior. I'll put okay, and then that was also 2 and 5. Okay, then you could also have alternate exterior, which means that they're outside. Angle 1 and angle 6 are alternate exterior. And 3 and 8 are alternate exterior as well. Now, notice angle 1 and angle 4 cannot be alternate interior because angle 1 is not inside those two lines. It can't be both because it's not alternate interior. And corresponding, we said that angle 1 and angle 5 were corresponding. So that only leaves us with neither. Is line L parallel to line M? So we're going to look at the two angles they gave us here. This one and this one. Notice here, this is that 124 is on the interior, and this 124 is exterior, so it can't be alternate interior or alternate exterior, but it could still be corresponding. Well, this 124 at the top is in the bottom left-hand side here of this line L, and line M, R124, is also on the bottom left-hand side, so those would be corresponding, which means that they are congruent. Okay, so as long as these two numbers match, 124 and 124, as long as those are congruent, they're the exact same number, then yes, they are congruent. If they weren't, we would have to say not congruent. Angle Q and angle S and segment QR. Angle Q is congruent to angle S. And QR is congruent to SR. Select the corresponding statement for the two triangles. Notice that this one is also congruent because they're vertical angles. So we've got an angle, a side, and an angle that are congruent. So ASA is what we're looking for. So that tells us right off the bat we can't use C and we can't use D. So we are looking for PQR. So I'm going to change my color because I want you to see the direction it goes from, because we have to match these up. P to Q to R. Now the reason I did that is because I want you to see this one has, Q has one circle there, R has two, P has none, but we started with P. So over here on our other triangle, we have to start in the same place. So we're going to start with T, and we're going to go the same direction, to S, to R. So our answer is B. The reason it cannot be RTS is because they would say then that angle P is congruent to angle R. Okay, classify the triangle by its side and by its angles. So we have one line and another line. That means that those two sides are congruent to one another. And then this third side has two lines down here, so it means it's not congruent to those two, it's just a different size. You also notice that it has two congruent angles, so that means it's an isosceles triangle. The way that I remember isosceles is I saw two. That's what I always think of. When I see isosceles, I saw two. I saw two sides that were the same. Now, we have a choice of either acute or right. Well, I don't have any right angles in here. They are all acute angles, meaning they are less than 90 degrees. So, this answer is B, isosceles acute. Identify the sequence of transformations that maps quadrilateral ABCD onto quadrilateral A prime, B prime, C prime, D prime. Okay, so the first thing that I notice is that C was up here. Okay, it was up here. And then it's down here. So I'm going to follow letter C. Because if I could stick with one point, usually I can find out how it moves. And we can figure out what the transformation is for these. So I'm going to say, okay, I want to rotate. I want to rotate around the origin 90 degrees. And I want to go like a clock does and go clockwise. So I'm going to write that down. 90 degrees clockwise. Because I know this thing has to rotate because it has to turn to get C at the bottom. So it was, if it's got a string here and it was one this way, now it's going to be one down this way. The string went up 3 to get to there. So now that string is going to be out here. And C is going to end up right here. Okay. So I know that kind of seems weird, but just picture this square. I always think of the origin. You've got, it goes to the right 1, So then when it turns, it goes 90 degrees, so it goes down 1. And since it went up 3, it went to the right 3. So it kind of turns like that. So then we can go ahead and map the others. So this one was at -1, 0. We turned. It's going to be here now. That'll be B prime. And then I'm going to erase these real quick for you because I think it's distracting as we're trying to draw our figure. Okay, so we've got that. Then A was to the left 4, so now we're going up 4 and to the right 1. And that was A prime. And then D prime was here. Is that right? 2, 3. Yep. Okay, so here is our new figure. Not the best drawing, but you get the idea. Now we need to move it over this direction. So I'm going to move it how many spots? I'm going to move it 1, 2, 3 spots to the right. So that means I'm going to add 3 to my X value. And I'm going to do nothing to my Y value. Because when we move it 3 spots to the right, 1, 2, 3, 1, 2, 3, 1, 2, 3, it does move it to where the figure is now. So really just watch how that turns. To describe a sequence of transformation that maps triangle ABC onto A prime, B prime, C prime, a student starts with a reflection over the x-axis. How should the student complete the sequence of transformations to map triangle ABC onto triangle A prime, B prime, C prime? So what we're going to do is the first thing we're going to do is figure out what it's going to look like after it maps and flips over a reflection of the x-axis. So the reason I'm drawing these lines is because I want to see there are 2 units between the triangle and the axis. So when it flips, there's going to be 2 units here too. And it's just going to flip straight over this x-axis. So it's going to end up here. Okay, so you're just going to flip it straight over. Now we're going to move it over. So it's going to have that reflection over the x-axis. And then let's see what we're going to do to our x's and our y's. So we're going to have to move it 1 spot, 2 spots, 3, 4, 5, 6, 7, 8, 9, 10. Because we started from point C, we're going to have to move it 10 spots to the right. We do not have to move this up or down any. So it was 0. If it was like down a spot, we would say -1 over by the y, but it was not. So this one was x plus 10 and y plus 0.